are still on hold, so I'm going to get ready to start the broadcast and begin, okay? So then Don, when I'm finished, I'll pass it over to you. Hi everyone, and welcome to our joint webcast with CMMI Institute, ASG, and Sandhill on the topic of the art and craft of data wrangling. It's not business intelligence, it's IT intelligence. The goal of this webcast is to help clients understand how the mature data management processes with enabling technology result in better data quality and deliver on the promise of improved data analytics. I'll be introducing our three presenters shortly, who will be reinforcing data management process improvement, enabling technologies, and the consequences of poor data quality. This webcast is being recorded, and we will follow up by sending out a recording link and the PowerPoints to the attendees in the coming days. If an attendee has any questions, please use the dialog box to submit questions. At the end of the webcast, we will do our best to answer them, and we will include the answers to all our questions in the follow-up communications. So with that, let me introduce the speakers. Melanie Mecca is the Director of the Data Management Product and Services at the CMMI Institute. Susan Habas is the VP of Product Management with ASG. And Don Soulsby is the Vice President of Architecture Strategies with Sandhill. And it is my pleasure to have three very prominent speakers presenting today. With that, I'd like to kick up the presentation by outlining the hitting side of big data, which seems to be getting more press these days. Don, you and I were talking about this, and we're now seeing in the 4 years the era of data scientists and most practitioners report that the primary occupation is still obtaining and cleansing and cleaning data sets. As some of us know, this forms 80% of the work required before the much publicized investigation skills of the data analyst can be put to use. Don, your thoughts?
Robert, it does seem to me then that what we're talking about is a great deal more about art than it is science. And that's one of the big things that we're dealing with now is what is the art of doing this and the science. And the term data munging or data wrangling is one that is used awfully in common with the data scientists, and the fact that they spend most of their time, as we see, it's like herding cats, all different types of data, trying to get them all on the right line, and then trying to load them into the big data constructs. With that, with the help of some tools, but it's mostly a manual process of trying to get all this stuff in the right place at the right time to load into the big data world. So in that respect, then, we do have some issues around the art of doing this rather than the science of it. As we look at how this world has progressed from the world of data analysis, this is a chart that came from a big data conference over in the Netherlands, and it looks like today with the world of data warehouse and business intelligence, we really are talking about information more from a historical perspective. And that's what we're trying to do here in the future of big data and predictive analysis, is trying to turn that sight from being hindsight to foresight to try and look ahead into a more predictive form of analysis as we go forward. The big question there, of course, is how does that relate to data quality? Well, in the traditional data warehouse BI world, we have these drill down type of structures that if we see a data anomaly, we could start to go down and, if you will, smell the bad cheese, and we could visually see where the data is wrong. So the consumers of business intelligence then will be able to look at it and say, yeah, I think we have an error here. Now, as we move into the greater big data scientist world now, that ability to discern patterns of error is going to be very difficult to do. So in other words, when we see an anomaly in a big data report, we pretty much go, huh, which frankly is an acronym that stands for Help Understanding Heuristics. And that's what's going to be the biggest issue going forward, is the number of algorithms and heuristics that are going to be used with the big data in order to perform the predictive analysis. So as we've seen then with the hindsight type of business intelligence, where we look at now versus the past, I call that observational analytics. It has already happened, so we have a pretty good idea when we look at the numbers. If they're wrong, we can understand, possibly because of the history, where it came from. So there's a certain level of data quality percentage then that we're dealing with in order to facilitate that and understand where the errors are. But as we head into the future with these algorithms that are going to be providing a lot of the analytics, we are going to look to the future where we don't have that historical referencing, as to the data quality. And in that respect, then, I very much suspect that the data quality has to take a significant increase. Little blog from Doug Laney, and we all know about big data, and we talk about the many V's of big data: volume, velocity, veracity. And Batman's response to veracity: no, it's not a measure of magnitude. In point of fact, veracity is about truth, and truth in our context is about trust, and trust only comes with verification. So we're really not just talking about big data, we're talking about all data, and if we're going to talk about all data, we should talk about data management as a whole. So really it's about the art and craft of data management, and art is about form and content versus craft, which is about the execution of a process that often involves a certain technique. In fact, the German word craft means power or force. Then if we look at the art side of data management, we see this expression from Eric Schmidt, the former CEO of Google, that all content is a very important thing, obviously, in the internet world, but his impression is that context is the crown to the content. So if we look at form and structure in the context of data management, the form is the structure and the context of the metadata of the data, also known as metadata. But if we look at the content, then we look at the meaning of data. It's expressed in some medium, and that medium might be an image. It might come from an email, or a different structure is the medium that provides it. And also what we're looking for in terms of content with regard to data quality is its conformity, so some standardized structure. So if we go forward now and we start to look at the context of this, we really are talking about the craft of data management. And when we talk about craft, very quickly we understand that it's a process and it needs improvement. But you also have to have a set of capabilities to understand what you need to do it the right way. Melanie.
Thank you, Don. So I would like to talk about the data management maturity model, which is a reference model of, hang on a minute, I'm having trouble with the slide here. There we go. A reference model that was developed by over 50 contributing authors with many sponsors over a period of 3.5 years. It is based on the architecture and approach of the CMMI development IP, which has been out in the world for about 20 years, and over 10,000 organizations have benefited from that approach, and 1,600 key appraisals in the last year alone. So we have borrowed from our big brother with significant data management content across the spectrum of the fundamental practices that lead to a very high quality data management program, as well as the individual disciplines and initiatives that involves. So the model has 6 categories, which I'll show you in a moment, 25 specific process areas, which were designed so they can be evaluated separately, even though, as I'll show you, everything is connected. There is quite a bit of content in this model, 414 practice statements and 596 functional work products. The practice statements are behavior. The work products are evidence that you are doing and following good practices. So if you take a look at the categories, we have data management strategy, which we feel that previous frameworks have not paid enough attention to. Because if you look over the past 20, 30 years in data management, you go to the conferences, you're going to hear that the main problem is the siloed project-based approach, and that it has been difficult in the past to sell the business leaders as well as IT on the importance of an organization-wide perspective. So we devote quite a lot of time to crafting a data management strategy tailored for the organization. Nothing happens without data governance on the left there, because the model is rife with data governance. We have one process area specifically about the practices and habits of good data governance. And then there are 102 of the 414 statements that specifically call out approvals, agreements, and governance. If you notice on this slide, if you look from data governance over to the right to data quality, you'll see that the primary, very high-level function that ties them together is metadata and the oversight of metadata. So governance provides metadata oversight that leads to and supports data quality. So that's what we're going to focus on today. And then we have platform and architecture, which are 5 practice areas that concentrate on involving the entire organization in ensuring that the requirements for the data management platform components and the architectural approach do meet the current and future needs of the organization. And data operations, which is essentially, we'll talk about several of those process areas today, how to do a good job with requirements, data lifecycle, and managing providers and sources. And Don will dive in on data quality, which essentially represents 4 process areas that comprise a complete 360-degree approach to data quality. And here we have the emphasis on the metadata oversight, where we're going to speak today. So we have talked about these process areas. Each one has specific practices that are capability directed in levels that reflect the typical growth path of organizations over the past 30 or 40 years. So the author team and the reviewer team, to get any kind of practice statement in the model, if you offered a practice that you thought was worthwhile in any of these disciplines, you needed to run the gauntlet of all objections and give a lot of implementation examples. We didn't want anything to be in here that was theory alone, unless it had robust examples that it had been tested and proven in real organizations. So level 1 essentially is the project-by-project ad hoc approach. So you can have organizations who have some really great accomplishments. You know, they may have implemented SOA and have lots and lots of data services. They may have implemented some spectacular analytics applications with visualizations and geocoding and genetics information, and they may have certain areas where they have significant excellence, such as a data quality center of excellence or other great accomplishments. But because the approach is not abstracted above the project-by-project nature, accomplishments tend to happen, and then they don't really get sustained and they don't get extended across the organization. So that's level 1. At level 2, there are additional specific capabilities in each discipline that the model requests or requires, if you like, and also the extent of those capabilities are more broadly scoped across the organization. And level 3 is essentially where the rubber really meets the road, because at level 3 there are another level of capabilities that are harder to do and take more planning and more governance and more effort. And also the scope is then organization-wide. So at level 3 you're getting the maximum of efficiency and cost savings and so on. Level 4 is the analysis of specific data management processes statistically for continuous improvement. And at level 5, the organization has bragging rights all around the industry, is sharing best practices with others, and is noted as a leader in that field. So as you rise in the levels, the overall risk from the data assets goes down. The data quality improves. The ad hoc approach gives way to leveraging and reusing terrific work products and terrific accomplishments and processes. And on the staff side, the level of stress and confusion and running around reinventing things again for the 50th time gives way to calmness and clarity and productivity. Just a moment here on the differentiation between capability and maturity. So capability is simply the ability to do something. So you've established and you're following a specific practice, a good practice, and you have supporting work products, for example, a process document or a policy that supports the following of the good practice. Maturity are supports to a process that ensure repeatability and also help with the stability of processes under stress to keep the processes from degrading. Let's say if you do a merger or acquisition or a major corporate event occurs, you will still have a stable process. So these are things like policy, providing training, providing QA, etc. Now today we're going to focus from the DMM side on 4 specific process areas that have metadata, like data lifecycle management and data lineage, and the integration of data and metadata itself. So the business glossary is the core, the central core of metadata. And we separate it in the DMM because it has been our collective experience that most organizations do not have a good business glossary. They have not approached it organization-wide. They don't have significant governance processes for it. And usually what you get is a collection of little business glossary silos in different business areas. Sometimes IT will do a chicken and egg approach and work from the logical data models to try to have a business glossary, but if the business lines are not involved with governance, then it sort of never gets critical mass. So that's why we separate it, because it's so governance intensive. The basis for the business glossary is agreements on the meaning of shared data. So I have one example I'd like to tell you about. This was a federal agency that happened to use a key term, case, and it referred to 4 different distinct business processes: a legal case, a bankruptcy case, a lack of premium payments case, and a benefits payments case. To the point where the Department of Labor, its parent organization, said, you need a unified case management system. And it required a lot of explanation on their part to say we're really using the term differently. So what that resulted in was a qualification exercise for the word case to separate these 4 different key uses of the term. And they did satisfy the department that they had thought it through well, and in fact they did not need a unified case management system. So that's an example of the extreme importance of agreement on terms and meaning. It also, the business glossary is also a very powerful collaborative activity on the side of energizing governance, to do things and have achievements and be involved in something meaningful and useful and collaborative. So the DMM has questions in the introduction section, and these questions essentially point out whether you are doing a good job. So if you take a look at the questions and ask the questions of yourself, you will pretty much know whether you're doing these things or not. And if the questions seem to be a little strict and a little hard to achieve, you don't need to worry about that, because essentially these are derived from the practice statements at level 3, which is an organization-wide capability. So these questions help you decide, where are we now? Okay, I'm having a little problem with the slide change here. All right. So metadata management, of which the business glossary is the core, is really where it all comes home in the organization. It is information about the data assets. And as you do more with the data layer and you try to leverage that information so that it can be centralized, approved, agreed on, known, and available, what you have is the core product that synthesizes all of the organization's knowledge about its data assets. Now, one of the problems with metadata management is that there are some wonderful tools out there. Rochade is a Ferrari-level tool that has endless capabilities. But sometimes what organizations do is they believe that their problems will be solved simply with purchasing and implementing the tool. What is required and what the model calls for in its practices is a very calm, rational, and strategic approach. In fact, we request at level 3 that the organization have an organization-wide metadata strategy, because you will not fully populate all the layers of metadata overnight. You won't do it in 6 months. So we don't want organizations to take a siloed approach and just grab bits of metadata and scan models and not do the work to determine whether the meta model needs to be configured or extended, or what the business need for the information is as well. So you need agreements and governance on the phases and the content of the metadata repository over time. So as we say, this is a core, persistent enterprise product. And you'll notice in this diagram over to the top right that the data management function appears throughout all of these 4 process areas. And that is essentially the staff, whether they are centralized or distributed, that consist of the glue that ties the persistent products together and ensures that they will be enhanced and that good processes and standards are followed. So how do you know you're doing a good job with metadata? Well, have you scoped it? Do you have meaningful phases? Are all the stakeholders who are key users involved in defining what will be populated and when and how, and what's more important to them, the process metadata with the scripting or the business glossary? They need to come up with the priorities and the scope. and then good solid processes and standards for metadata collection, metadata changes, and updates. So in the DMM, the data management lifecycle is essentially for the organization to consider best practices for the control and traceability of all of the data assets that are key to the business needs, from the creation or acquisition all the way through to archiving or retirement. And it really requires a great deal of approvals and governance from the business to make sure that this is being done. And a metadata repository is the premier approach to capturing all of this lineage. I've talked to regulatory organizations in the past who have regulatory reports from multiple sources, and they have a terrible time determining what is the date of a snapshot, for certain trade reporting, etc. So it can be very difficult. And data lineage is, for many purposes, one of the holy grails of the data lifecycle. Now, for data integration, it is extremely important to have good practices for data integration, and of course, to develop a target architecture that builds out and implements these practices. So the idea is to streamline the architecture, consolidate redundant data sources, improve availability and quality. So it's also important to integrate the metadata and get it out of the pockets and have it centrally accessible, locatable, and mapped. Okay, so a well-architected data layer and accurate, crisp, timely analytics are some of the end goals of doing sound data management practices. And now I would like to turn it over to the next presenter.
Thank you, Melanie. Let me just move ahead a slide here. So one of the important parts to me as well of the CMMI Institute and the data maturity model is the component related to education. And there's a website that you can look up to that will talk to you about what the model is, but more importantly as well, the education to get a better grips on what is involved in doing it. Robert, can you move to the next slide, please? So I encourage everybody to take a look at the website and try to avail yourself of the education. I myself have just finished a qualification for the data management expert role, and I passed through all of the data model, and I've seen the value of understanding the model itself and then assessing the capability of understanding what level you're at. So what we're really talking about here with the data management process of trying to get to a level 3, which is, as Melanie stated, is that kind of enterprise-wide capability, and the maturity level at level 3 means that you're pretty much doing the whole job across the entire enterprise. To be able to do that, though, you do have to judge how you're doing, and we've understood that from the business with the things called business intelligence and data warehousing, that basically through the pipeline of the business flows money, and we can see that in evidence by the fact that when we build data warehouses and we build business intelligence, that typically, if you will, the fact table is pretty much all about money. Well, if we look at the IT environment then, and we look at our world of pipeline, what is it that throws through our pipeline? Well, our abstraction of the process we do is actually metadata. So if we talk about building a business intelligence system for the CDO, we really are talking about intelligence that relates to IT, and the flow there will be metadata. So if we look at a traditional business intelligence system, we see that we have the source data, the ETL, the data warehouse, and then the business intelligence. Well, if we were to flip that to the IT world now, let's look at the similar components that would do for business intelligence for IT. Well, we'd also add models just from the data itself, so the abstraction of the data. And instead of an ETL tool, we would have these scanners, which would now flow into a metadata repository, which in effect becomes the data warehouse for IT. But we have the advantage of adding a glossary, which gives us, as Melanie had said earlier, that foundation core of metadata that actually comes from the business. So with that, I'd like to talk now about the form of data. And with that, I'd like to pass it over to Sue, who's going to give you a better understanding then of how the glossary and metadata management will help us build this IT intelligence.
Great. Thank you, Don, and thank you, Melanie. In this portion of the presentation, I will bring to light what applying a data management tool to data wrangling will enable to both the business and the technical user. I'm going to outline the value of this effort and what careful considerations to data quality will provide to you as an architect or as a data wrangler or simply as a consumer. In starting this section, I will talk about what we see in the industry today, the issues, and the evolution of our business and IT landscape. From here, I'm going to discuss the art and form with some specific tool examples that are needed to provide rapid, accurate, trusted data value and results. And I think you passed me the presentation, right, Robert? For some reason,
Yep.
It's not moving.
So you should be able to just use your arrow up, down button. Let's just make sure that this is the screen. Go ahead and use your mouse button to click, see if that's fix the issue.
Okay, it's not moving to the next section.
Yeah, you do have, it could be that I'm fooling about with the keyboard and giving you the, taking that away from you. So let me just give it back to you. So try it now. All right, so let's go. Yeah, let's go old school, Sue, and just tell me when you need me to go to the next slide.
Okay, sounds good. So if you could go to the next slide, that'd be great. All right, perfect. So the data landscape has always been very complex with many different types of data, many more data entities, and a vast number of connections. The heritage systems are still doing their jobs, which makes it a little bit more difficult to evolve. With the emergence of big data or data wrangling technologies, it's really exploded the landscape. Add in the emergence of help yourself or on-demand analytics outside the control of IT, and this makes the management challenges even greater. So the keys to navigating complex landscapes have always been gather the information to draw the maps, trace the data back to the source, understand how the information is moved and integrated. So getting the keys in hand and knowing how to use them is a craft, and it's also the key to data management maturity. Next slide. The business and IT are engaged and finding new methods of collaborations. Data element context and contextual hierarchies pinpoint how data is categorized, viewed, and governed from that business perspective. Your data environment is held with high regard with continuous funding if the accuracy level is high and business value is achieved. For this, a bird's eye view as well as detailed analysis is really important. Due to the big data volume and veracity, it is simply impossible to keep a well-kept business pace doing things manually. We are advocates for structure, automation, and a well-modeled layer to provide a window onto what's really happening with your data environment. Next. Architecting your data space to ensure data transparency, quality, and business alignment is essential to the overall success of wrangling. Each design has its own unique requirements essential for driving business value. So there is an art to shaping and structuring your design before, during, and after that build process. So questions like where will you invoke the process of understanding where and how data is being used, securing that data usage, and how you will align to business policy and standards. These are all we should be asking ourselves as we build our big data lake. To what degree will you establish this foundation? Will it be automated, a true representation of what you have built, or something done after the fact with spreadsheets, SharePoints, or just simply pieced together? Will you always need an SME or a subject matter expert to get to this root cause of analysis during data issues? All right, the next slide. So we believe it's imperative to easily understand that raw materials of the data itself. It should not be a lengthy piece-together process to understand the source of the data, the calculations, aggregations, or where the data is being distributed. Questions as to the integrity of your data should be readily available. Was this data linked to a business process, linked to a standard? Does the source conform to our data standards of completeness, accuracy, and timeliness? How do I collect this information? How do I pull this information together? Today I probably use a spreadsheet. What happens when changes are made anywhere along this pathway? How is this information managed? How many resources do I need to do this? There's a metadata collection process that should be seamless and it should be automated. Once this process is established, it should depict how data is represented in our physical landscape. It should be consumed in an automated, transparent fashion to convey a precise disposition of your data, where it's sourced and how it's being used. So, recognition of today's landscape evolution. So let's start with today. So within IT, we have extremely diverse landscape with a range from mainframe to distributed environments, relational database environments, and the new analytical big data lake. The diversity of our data architecture has matured and expanded over time as well. So our operational systems have become the base to many source and delivery systems for key data frameworks like the EDW or perhaps your master data management hubs. Data movement tools have also evolved in a similar fashion. We continue to maintain the open source distributed and messaging tools from a pre-ETL era when then we standardized on the ETL, so Informatica, DataStage, SAS, SSIS, and we continue to expand the growth of that data lineage through SQL parsing for various forms of SQL found in Oracle or Teradata or Netezza, etc. So with each new corporate project, it will require agility in finding their product, consumer, or financial data quickly, and they will expect the data to be accurate. Changes to processes and policies will occur, and we must respond quickly to these impacts. The business has evolved to a new level of sophistication. It used to be that the business writes the requirements and then passes it over the wall to IT. Now IT and the business process is collaborative, it's engaging, and it's also incorporated into the data cycle. The IT business governance process is dependent on key business artifacts and processes that represent the corporate definitions, its policies, standards, and guidelines, regardless of the technology that's used or the framework that IT is using. Next. The current phase of the IT transformation offers an endless array of powerful, cost-effective technologies to clean, to integrate, and to investigate the data. But there's a lack of structure as well as an effective business layer onto this technical environment. As business leaders engage more with this new shared environment, the need to understand where the information is coming from, just how data is shared and used, have amplified. Hence, the birth of data sharing agreements between LOBs that are putting their information into the big data lake, cost justification guidelines, security requirements are also becoming a big part of the day-to-day life cycle. If you hit click again, it'll bring in a couple more animations. Data lineage in and out of the environment is taking a front seat. So in concept, none of this data is created inside of the big data lake. Therefore, there's a big reliance on the external forces that the environment is fueled with validated and sound data. So there's a tsunami of information when you consider the bird's eye view of information operational source systems passing through the VDL and being distributed outside of VDL for use of reporting and BI tools. So quickly understanding things like where is the product data versus the sales data located and sourced from, and how quickly can I find this information to make the right marketing data to support seasonal campaigns or tracking a compliance issue. It could take weeks or months to find, change, or parse the data if doing this piece by piece or manually. And there is a high reliance on subject matter expertise. So with this much volume and veracity, how will you achieve this business agility? The business data lake guidelines and data sharing agreements foster ownership, and metadata provides transparency and traceability of the data. Next one. All right, so we have a new form of art. It's the business assets. So let's talk about these new business assets. At this juncture of the evolution, we're striving to place structure and form behind the business process and the assets. The business is establishing its own set of artifacts, whether they're creating them manually or with tools. These artifacts must be managed. The question as to what level will they be managed and structured and incorporated with the physical information is a very relevant question today. Next. So what is needed? The TER, the tsunami evacuation route. There's tools that provide you with this art and form. They must have automated extraction methods from a diverse sea of technologies, as we saw in the last few slides. They should have the capacity to extend and create new forms of data extractions as your technology environment expands and grows. There should be a business model that connects the physical metadata that underpins that visualization layer. And it must remove the physical complexities with powerful data flow visualization capabilities and provide you with that cross-functional bird's eye view. The data management environment should provide you with the full capacity to govern and guide your individual data projects. It should be flexible and an open solution that plays well with other technologies and also supports the diversity of your traditional and big data landscape. It should provide you with a targeted means of getting started with much room to scale and not fall short of any business or technology aspect. Next slide. In this next slide, we're going to talk about the art and form, and we're going to show you the blueprint of how we usually instantiate or start a project. So take, for instance, this blueprint with from the heritage environment. The goal of the blueprint is to map out the scope of the information needed for end-to-end data lineage. In this initial phase, we map out all the programs, the batch files, applications, schemas, and report universes involved with this particular data environment. This is the topology blueprint of your build process. Next. With the heritage systems, you should be able to see this end-to-end data lineage from the MAINFRAME through the EDW.BO and out to your reporting environment. It should be easily readable to the business or the technical user. There should be dynamic drill downs that provide deeper meaning as to the data movement, the calculations that were applied, any sort of reference data or codes that were used, and rules should be available from this graphical view. There should be various viewing formats for extremely large data environments. And finally, the capability to be able to export this information to a form of your choice that will help you pass a compliance audit, help you share the information online with another steward, or just print graphically and readily and take it to your next meeting. So the evolution from a data lineage aspect moves us from passive to active by sharing this information and providing that online data validation across that vast technology landscape and across line of business borders. Sorry, we're on to the next one. Okay, so the new world art form blueprint. So let's take a look at this. Again, it's really about the stuff you are putting into the big data lake. We are talking about the structure and the form of the information, not the content. So in this representation, we're seeing distributed code that represents a .com environment. So we want to know where is it sourced, how is it structured, and what technical and business rules were applied to the source application. We're scoping and framing the project with a topology or a blueprint of how we're going to implement and initiate the information in the tool, which is the next slide. So actually, this is not the tool slide, but this is an appreciation for Java parsing. So this Java code representation in its raw form should help us appreciate what you're going to see on the next slide. So a tool performing data lineage should be able to parse that information and show you the data lineage from both a high level and a detailed level analysis. Again, the business really doesn't care about the technology, but it wants to understand the source and the path that the data follows. Lineage starts from a high level and dynamically works its way through to the detailed level. And this plays very nicely to both business and technical users who want more information. The lineage can be tied to a business term, a rule, a policy, or perhaps even a portion of the reference data. Next slide. So how do we get started? We're back to this question of where do we start with the tsunami of information? The starting place is pain. Where do I run the risk of exposure? Where have we tripped up with data mishaps in the past? What's causing large delays with key business campaigns due to issues? Our recommendation is to start with critical data elements and critical business elements, or what we define as CDE'S and CBEs. The CDE'S are elements that, left unmanaged, could cause extreme issues of risk, such as financial asset information in a bank, personal identification information being exposed, social security numbers, customer net worth, net sales, etc. There's actually an interesting new Gartner program coined Information Advocacy that outlines an ROI calculation that compares over time a managed CDE to an unmanaged or untraceable CDE. It directly measures business impact. I have to think that this would be a great activity to create for a baseline of your data management program metrics. So what happens when we don't apply any context, definition, or business rules around things like revenue, address, phone number, tax ID number? What happens when we report and make decisions based on unmanaged source systems? Okay. The art form. So let's draw the full picture. Business terms, policies, standards, and guidelines have procedures, rules, and service level agreements. These business artifacts are created and collaborated on by business stewards through an automated workflow and an approval process. The business artifacts are joined to critical data elements, that's the next click, which are represented at any hop within the lineage, say a report field or a column, a calculation rule, or a source field. The authenticated source is marked as being from a source that has been profiled and governed. The conglomeration of this information will provide the overall story, for instance, of a new corporate policy where data such as customer income figures must be at the highest level of security. Customer date of birth must be a required field for product and package offerings. Customer deceased date must be recorded to stop those mailings. These policies can be shared and viewed online as the standard supported by a CDE with a business rule and derived only from authenticated source systems. Okay? So to what level of automation and maturity are you aligning your data to? Next. Next, we're going to talk a little bit about data quality, so adding some more color to your canvas with data quality measures and reference data. Storing and associating data conformity rules to your critical data elements online provide instant data verifications. These rules and standards can be tied into the valid values, so where the codes are viewed online, with the standard business definitions governed by a workflow, owned by a steward. So let's take a peek at what this can convey to the end user. Next click. So these are some snapshots of a business unit that's tied to another column within a different table in that database. So it's the source and column. On the source side, we have a drop-down that first conveys what and when the information was profiled. Next. And the next piece shows the actual conformity rule. It will bring in the pass-fail metrics. In this case, the source column did not meet the allowable threshold of 98%. Next. Following up on the target side, if it didn't establish or meet that threshold at the source, it's not going to meet it at the target either. But you can see these metrics at any pathway along that data lineage. Next. All right, finally, preventing these consequences of producing value. So what are the consequences? Just general unmanageability of this environment. Also, as we started, 80% of your time wrangling versus analyzing the results of your good work. Reduced business agility that is delayed or handicapped by incomplete and untimely fixes to data issues. And God forbid, regulatory risk and exposure. The value, increased business engagement, trustworthy data, quick data facts, the overall ability to use data for its original intention, and that is to make better, fact-based business decisions to grow and sustain your corporation, enabling that data confidence. Next. And finally, one little pitch on where ASG is with its Rochade technology. We are in the process of launching the biggest release ever. It's called DG 2015, and it represents the data governance must-haves from a business capability standpoint, such as data governance reports, dashboards, multi-level approvals, veracity role management for stewards, and issue tracking. It also expands on our defined core capabilities of data lineage by providing fully automated Java and distributed lineage snapshots, so being able to go back to a point in time and understand how the data flowed. Stitching, which is actually human-enriched activity where it makes sense. Data lineage compliance reports and dashboards. Simplification efforts have decreased setup time with a silent install, glossary bulk loads, hierarchy role management, and increased unification steps between the language analysis and parsing with the database scanners. So our value proposition to govern and guide your data projects with powerful mapping and data flow visualization coupled with a highly accurate, trustworthy, economical approach to data compliance and data management activities. And on to the next panelist.
Thank you, Sue. So I hope you're seeing a pattern that we've established here, that we are talking about the importance of the integration of business and IT, and can't say any stronger that the notion of a business glossary where there's approved business terms and then leading into the metadata, the technical side of things that show the critical data elements. And it's the marriage of those two things that will provide that bridge, which we typically, again, have seen has been confusion between business and IT. So we've seen a bit about the craft of data management. We've seen a great deal, obviously, about the form or the structure, the metadata. I'd like to talk to you a bit now about the content of data. It's really about data profiling. And as we saw earlier when we talked about content, as we head into the lake, now I apologize in advance, I'm going to try to keep the data lake jokes to an absolute minimum, but as we head into the data lake, we have all heard once again of the three big V's of big data, the volume, the variety, and the velocity. And that's one of the critical aspects as we start to deal with the big data world, is these three things and how they're different from the traditional world of data warehousing and business intelligence. Let's look at variety for a moment. Well, there's a number of things that we're looking at in the variety world, and mostly they come from either code-centric or things that are structured as a result of some software, or text-centric big data. And this is things that actually come from some human involvement where language, the human language, is involved. So if you think about it then, the two sides of the variety really are about software language and human language. The thing about text-centric big data, as we see by the human-generated world and by the web or social media, is the misrepresentation that it is unstructured. Well, if we start to look at unstructured data, I remember growing up as a kid, we had these charts about what language was. It had subjects, it had verbs and nouns and adjectives, and in point of fact, there actually is a UML schema for the English language. But if we look more closely at what is the important data that would come from big data as it relates to this so-called unstructured data, it's the notion that most of it's observational. So this would be things like a medical report or an accident report. But one of the more interesting ones we've seen is where there are conversations. And this is typically, again, where we start to look at things coming from call centers, as an example. So it's all highly structured, it's just unclassified. So I'd like to make that comment to start. Let's talk a bit about speed now and velocity. For those who haven't heard about the Heisenberg effect, that's where when you look at the experiment, you actually change the result. Well, it turns out we have a Heisenberg experiment as it relates to data quality over time. When we get data brought into an area, whether it's big data or a data warehouse, we assume because of historical information that it was at a certain level of quality. But it turns out only by inspection, which happens at a period later from typically when we load the data, that we find out through some metric or some reporting that it's not quite the data quality we expected. So it kind of drops down and then it heads back over time up to a higher level. So let's look typically now at a big data architecture. Then as Sue had mentioned earlier, very little, if any, data is actually created in the big data world. Let's take an example from the IBM world or the Watson world, and you can see then that inside the blue is the area where the big data operates in the data lake, and we see that the data types are actually things that are brought into the data architecture. So we see that there's machine or sensor data. This is probably more representative of that V volume that speaks to the large amount of incomprehensible, huge amounts of data we're going to stuff into the big data world. But clearly, obviously, there's things with like images and videos. There's enterprise content, which typically is the emails and things that come from a text form. And again, there is the traditional volume of data that comes from what we know today in the data warehouse, transactional or application data. But we're also looking at social media, again, which can take the form of image or text as well. And certainly we're looking at third-party data where we would buy large volumes of data to bring into our predictive analysis world. Well, here it is, folks. Here's the data lake joke. I worked in college for a pollution company, and we remember at a period of time where Lake Erie was officially pronounced biologically dead. And the reason for that was all the stuff that was put in. So I guess the message about data quality then, as it refers to the big data lake, is we have to be careful about the data types and the quality of data that we put into the data lake, or the result, again, much like we found in Lake Erie in the 70s, is that the lake itself will become so highly polluted. So really it's about the data coming into the lake that we're going to take a look at. So in that context then, I'd like to add another element of the DMM. I'd like to add a bit more information about data profiling. So as we look at the DMM itself, there are 8 criteria. The traditional data quality world, if you remember, was CATS, complete, accurate, timely, and logically sequenced. But we can increase that to a larger degree with some other areas of data quality that I think are just as important for us to understand, provide us a standard by which we can judge, and then look at a measurement or a metric by which we are saying whether or not we've achieved them. But you'll notice as we go through the 8 different qualities of accuracy, completeness, coverage, conformity, consistency, duplication, integrity, and timeliness, that the key word there is a criteria. And in this sense, it's almost like a requirement that we state this is the level we would expect to see in each of these different areas. And deriving those criteria are one of the most significant aspects of a data profiling exercise, because in certain respects, they become the requirements document for the data quality. So then as we start to look at it, accurate and complete, well, what that means, frankly, is you do have a pattern. You understand what good data looks like, and you understand that it has several components. In most cases, as we look at something related to data quality, there is very seldom a single transaction that will form the whole structure. In other words, the whole fish. So an example would be an order. An order itself may actually come from several different applications for customer contact, for creating a new customer. If an order is placed that currently is not a current customer, we may actually look at the order itself, and the fulfillment of the order may take several steps through logistics systems and delivery. So in that respect, when I say, do I have a good order, I would have a number of components to look at. So one of the critical things for us to understand then, as the data comes in that we're going to load to the data lake, do we have a complete fish? Do we have all the elements that form the complete structure? But then again, do we have a recognizable fish? In other words, is it accurately described as we load the data in, and then having a metric as to discover if it's correct or not? The issue we often have is we take the sequences of transactions and we get them out of sequence, so we can't understand what we're really looking at till very close to the end, and then we also find by the end that we're actually missing some part. So the integrity of a transaction structure that forms a larger business transaction, a customer order, itself might have several different transactions, and it's important for us to understand what each of those transactions are from a systems perspective to try and build that appropriate level of quality into the business transaction called the customer order. One of the biggest areas we have today, we know about part of the reason we need data lineage and traceability is the fact is as we take data from one place to the other, something sort of happens to it along the way, and by the time we get to the other end, it's not recognizable at all. So there's definitely situations where we need to look at a standard, and that standard needs to be consistently applied to each of the transaction systems. For example, a zip code has to have a structure, and every time we say we use that key element of zip code, that it has that conformity to the predefined structure. And then as we duplicate that information across, we have to be very careful that transformations don't happen to it, so by the end, when we get to the data lake, and we look back to see where it came from, it is unrecognizable because it did not conform to the standard. So we look at the big data metadata. Really what we're talking about is the metadata of the data types that are entering into the big data. So we look at machine and sensor data. Of course, it's machine generated. So there definitely is structured metadata there. It's just a question of discovering which machine created the data. It was software that created the machine, and therefore the software must have some sense of metadata that we could search, find, collect, and then put into a repository. Image and video data tends to be what we call in the data terms a blob metadata, but in and of itself is also created from a piece of equipment or machinery. Therefore, there is some data that is there that we could bring in terms of metadata, such as who created it, when it was created, what type of machine created it. Enterprise contact, again, is more of the wetware or human side of things, and this is things like emails and structures that come more from a text world. But as we mentioned a little earlier, it's not unstructured data. It just needs to be classified. So the process of classification will also generate metadata and help us with something called text disambiguation, where we take the meaning of the text, provide it into a structure that we can then put into the big data world and allow us to collect the metadata around what that text means. Application and transaction data is very similar to what we're doing today with data warehousing and BI. It is very structured metadata. Why? Well, it was software generated, and once again, the programming language we can look to see what the structure was of the output of that software. Social data is kind of interesting because it is a combination of text and blob data. And then again, once again, if we look to the text disambiguation for the social data coming from things like Twitter and Facebook, we can also look to the blob metadata, again, once again, equipment generated, and look at either the cameras or the videos that created it, get the GPS information. There's a whole layer of metadata that we can add even from the social data world. And then the third-party data, we really should be talking about the SLAs of the metadata there, because once again, typically, the third-party data is software or machine generated, and we should have the metadata. In point of fact, in the service level agreements we have with third parties, we should see the 8 elements of data quality as part of that service level agreement. Let's take a look a bit quickly then at what this taxonomy then of these data structures. So we really see things like in domains, we have string data, we have numerical data, we have some date time information, we also have blobs. As I mentioned before, most of the image or videos that we see are defined as a blob, which is a binary large object, and it's a single entity that includes videos and images and things like that. Of course, reference to a movie of a big amorphous glob, but in point of fact, it is more than that. We do see that there is metadata. In point of fact, if you ever look at an image on your phone and you open it up, you'll see there's a whole rich structure of metadata that's behind that photograph. And we see that there's some new technologies of recognition that will allow us to even create more metadata. But fundamentally what is there is who created it, where it was created, how it was created, certain elements like what the frame speed was on the image, or what the aperture was if it's a photograph. And certainly with the GAPS technology, we can also tell where the photograph was taken. So all that metadata could then go into the big data lake. It would allow us to do much more traceability. So getting back to the notion of a service level agreement, very much so if we're going to get third-party services and third-party data, we should have all of those metrics, the accuracy, completeness, coverage, conformity, consistency, and duplication and integrity, as metrics that we say when we get data from third parties, what level of quality would be required for us to accept the data. And in point of fact, given the most information is coming into the data lake or big data environment from another source, we should deal with any source going into the big data world as having a service level agreement that includes all of these areas of quality, even if they are internal. Let's talk about metrics then. So anything we talk to in terms of these metrics and measurements is typically a percentage. It's a 95% correct, it is 20% complete. But we know from an adage going back to the world of data management, and we look at the world of business management, that one of the big precepts of business managers is you can't manage what you can't measure. Well, measurement then, again, is this observable standard, an observation against the standard, and that forms the ratio. So it's very critical to understand if we're going to do these metrics, and we're going to look at using these for quality assessment, that we have to understand that we're going to look at an observable number, typically coming from a data profiling tool, but the critical aspect there is a standard by which we then judge. Now, if you all remember the movie Spinal Tap, they said, well, they had louder amplifiers because their amplifiers went to volume 11. And this is the critical aspect of the standard then. If you keep changing the standard, and every time you judge the metric of the data quality, you can see that the metric you're providing, the ratio, the percentage, is not going to be very meaningful if you keep changing what the standard is. And a little plug on our side for the Sandhill consulting world is we have a product called Enterprise Modeling Set of Standards. And it is precisely that. It is about naming standards and domain standards and valid values that say, if I were to look at the form of this data, here's what it should look like. And then we have a way of then producing that into a process by which you keep these standards, that when you then use a data profiling tool and create that metadata, you then have a way of having a process that defines a standard that is reusable. So before you jump in the lake, well, if you all remember any of the great submarine movies, every time the captain says dive, the first thing somebody does is to run over to a board that looks a lot like this, the rig for dive board. And that's what we're advocating in terms of how you do your data quality and how you, before you go into the lake, frankly, is to have this type of rig for dive. Once again, it would be a metric that says, I'm not going to put stuff into the big data environment until I know it's of a certain quality. And then you could build this dashboard. Here we have complete, accurate, timely, and sequenced. And this gives you an example like a rig for dive that you could use for data quality, backed up by a service level agreement, and then have this kind of scorecard that says, I'm not going to even load or try to do any predictive analysis until I know I've reached a certain level of data quality that will provide me with the results. And of course, having that integrated into your data management and data governance system to then advise people that you're not going to do certain aspects because of the quality or lack thereof, and to have that integrated into the management program that allows you to then fire off an email to the appropriate steward to say, look, this isn't going to happen because it's not up to snuff. So we've talked a great deal today then about the craft, the process of doing data management, a bit about the art, which is the form and the content, form being the structure, the metadata, the content being the data quality, and the analysis from data profiling. So the big question is, this sounds like a pretty big molehill to climb up of, how do I get started? Well, if you remember Alice as she wandered through Wonderland, came across this cat sitting in a tree, and she was a little confused as to where she was, so she asked him, the cat, where should I go from here? To which the Cheshire Cat responded, well, that's a great deal, depends a great deal on where you want to get to which Alice responded, says, well, I really don't care very much. Then the cat says, then any which way you go is fine. The key to remember here was once we get started is we need a clear understanding of where we want to get to. And this is what Melanie cited earlier, that having a strategy, having an understanding and executive support of where you want to get to. But that's very important to have, but the second most important thing, of course, is a map. You really need a roadmap to understand the path you're going to take rather than just the notion that you do want to get somewhere. And we think that the data management model, maturity model, is a darn good map. It lays out a whole bunch of sections on what you have and what you need to do, but it also gives you an idea of the route you can take to get there, to get to your level 3. And of course, the most important thing about understand about any map, much like a mall, if you go into, is the little star, little dot that says you are here. It's really hard to know where you're going when you don't know where you're at. And we feel that doing a data management assessment is a critical part of this understanding for the two reasons. One, it lays out this roadmap for you, and then again, having a semi-automated or helpful process through a set of enabling technologies to help you get further down the road. Again, taking a look at the data management maturity, we want to get you to level 3. We believe that having that defined process across the entire organization is the thing that's going to get you the level of data quality you will need to get that promise that comes from the big data world. So really it is the power of level 3, and I can personally speak to, again, having just recently gone through the program, to be a data management expert to help you guide you along that path to get you to level 3. We consider as an important part of this process. By the way, just to give you some example of some recent anonymous results that have been done from assessments, you'll notice that that box that represents level 1 through level 3, that very few of the processes we have seen are actually breaching that level 3 amongst the assessments that have been done. And you'll see, by the way, there is no 0. You are doing something. So you're starting at level 1 and trying to raise yourself higher on the different levels. So critically, again, what we talk to is having that roadmap, understanding what the elements of a good data management program are, having a very sound foundation of where you are, and then a process by which, through a bunch of iterative steps, with some enabling technologies, you can get to the higher levels. So, Robert, I'd like to pass it back to you now.
Thanks, Don. For folks listening in, Melody talked about the CMMI and the DMM, and we, Sandhill, see that as a critical framework for clients to work with, and we're supportive of that. Sue talked about the need for a metadata repository and the ability to pull in old and new metadata for the business to use, and we see Rochade as a key solution for clients who are looking for metadata repositories. Don talked about the need for accurate and complete information, and of course that's where we see how Sandhill can help. Following the data maturity lifecycle, we are partners, and if you just click through the next slide there, Don, we are partners with ASG Rochade, and so we can obviously help clients evaluate metadata repository. We are partners with CMMI, and Don had mentioned earlier that he is a DME expert and can obviously help people through the initial stages of the assessments, and certainly that's where we want to look at. And obviously from Sandhill's point of view, we provide sales support and training as well as the assessments, so we can help you understand where you're at today, understand where you want to go, and can lay out a roadmap on how to get there. And from our point, in as a summary slide, where we see things is that, you know, we kind of had some play with the snakes and ladders, right? And so if you're not careful, if you don't do the governance correct, if you don't have the right compliance, you could find yourself slipping down that slippery slide back to square one. Where we would like to leave some thoughts, and we'll go into Q&A shortly, but where we would like to leave people thinking is that the first step in any kind of end game is to really do the assessment and understand where you're at and where you want to go to and how you can get there. That's our recommendation. When you know where you're at, you know where you're going, and you can do it the right way. And Don, for people that want to follow up on the assessment and follow up on the information, I've got my email and a PowerPoint. Please email me directly and we can have an in-depth discussion. And Don, this is your solution, or your end slide. So I'm going to let you explain that while I bring up some Q&A that people have been interested in. So.
Sure, and thanks, Robert. Yeah, and this thing we've always found that we've been dealing in the metadata game This is a very, very old Tibetan proverb that holds probably true today as any other time, that if upstream is dirty, downstream will be muddy. And this is very obvious, again, as we talk about the big data world and the art and craft of the data wrangling. If we continue to think of adding dirty data into the big data environment without the mature data management process, without understanding the metrics associated with data quality, we will be putting dirty data into the data lake, and not surprisingly then, the results will be very muddied. So with that, again, that's our message. We'd like to talk, once again, the art and craft of data wrangling is really the art and craft of data management. The craft is the process, the execution with the technique, and the technique is defined inside of the CMMI Institute's data management maturity model, and your process of improvement then is to take those capabilities that are outlined there and move along that roadmap of maturity. The art part of it, of course, is related to the form and the content, and the form being metadata, understanding structurally about what your data is, and then and as a way of looking at the content then, looking at the content as the meaning of data within each medium, and each medium has its own distinct metadata, which we need to harvest and put in a central place. So hopefully that gives you a little better understanding then of what we started the conversation with, of the art and craft of data wrangling is really the art and craft of a mature data management process. Thank you.
Thanks, Don. And just a quick update for some questions that we had being brought in here. So if you just bear with me a minute, I will look up the questions that came in here. I think the first one was a cross between a question between Melanie and Sue. So bear with me, guys. So Sue, just for your information, you know, can you answer the question? How did the data quality? So how do you display data quality metrics with the lineage that come in from a data quality tool?
Okay, great question. So what we have coming out in our latest version is a scanner from a particular profiling and metric tool called Trillium. And what that's going to give us is the end results of that data quality analysis, as well as the metrics that were used to create those profiling metrics. So we will scan them in automatically from the Trillium database, and they will be linked to the data elements or columns, entities, attributes within the metadata repository, so that you can see them online whenever you search or perform data lineage or impact analysis on that particular data element.
Thanks, Sue. Another question has come in. I already have a data governance tool, but it does not collect the physical attributes. How can I extend my current environment? Sue, Melanie?
I can definitely take that one as well. So what you're looking for here is a way to offer a portable data lineage solution, or maybe a portable metadata repository solution, because you don't want to do that manually. You probably want an automated process that collects that information on a regular basis. So in a tool such as Rochade, you can use the Open Java API framework and connect that and just purchase the components that will give you that data lineage and that physical metadata on a day-to-day basis. And that would support the framework or the architecture of your data governance tools that you're using today.
Great, and I think I've just got one more question coming in. Question says, it seems like a very long project to build and deploy. Are there any quick and easy wins that the client might employ?
Definitely. You want me to take that one too?
Yeah, so yeah.
Okay. All right, so definitely there's a lot of easy wins. So again, we'd start with that pain point. And you can start either in the physical environment and understand a certain application or an enterprise warehouse or an MDM hub, or perhaps you want to start on the business side and start just collecting business definitions and standard policies Or you could do a hybrid solution. So you could start with a particular glossary in a line of business where they're naming those definitions and they want to get started just creating those definitions and associating it to a particular database or maybe a model that they have from a physical standpoint. So there's a lot of easy ways to get started, and we try to scope that into an iterative process, starting with perhaps 60 to 90 days for your first rollout around that initial environment, and then scale it from there.
And just to add to that, traditional business intelligence and data warehousing, I think, is a pretty good place to start, because most of them are automated or tool-generated metadata. And the two questions that we run across very typically in conventional data warehousing and business reporting is the two questions of what does it mean and where does it come from? And these are very critical questions that typically happen when a new report is presented to a business person. They typically have those questions to ask. So if you think about answering those questions in a very quick, orderly fashion within that 60 to 90 day frame, and then creating a pattern of behavior of how you're answering those questions, just think of how then, as you would proceed to the big data world, where you're going to get that very similar, possibly non-intuitive answer that people look at and say, geez, I'm not so sure that means or that looks right. The what does it mean and where does it come from has become a very critical aspect of big data.